Hi, my name is Mackenzie Masick, and I'll be telling you a little bit about Wake Turbulence today. So to start off, we're going to be looking at a few pictures of a Piper Warrior, and we're going to look at the wing and its components. So here is a Piper Warrior from my flight school. This first picture is pointing to the leading edge of the wing. Here is the wing tip and the trailing edge. Going back to the wing tip, you can see we have the upper camber and the lower camber. So camber is just another way to say the curvature of the wing. So you'll see the upper camber is much more curved than the lower camber. So how do these components create lift? So we have Bernoulli's principle that states when the speed of a fluid increases, its pressure decreases. So we talked about the upper camber being more curved than the lower camber, which causes the airflow over the wing to have to travel a further distance than the air below the wing. Because of this, it has to increase its velocity, which decreases the pressure. Because of this, we have low pressure over the wing and high pressure below the wing. The difference between these two pressures results in lift. It's also explained by Newton's third law of motion. For every action, there is an equal and opposite reaction. So when the air pushes against the wing pushes back, and the result is lift. So why are we talking about lift? So you need lift for wake turbulence to occur. Since all aircrafts create lift, all aircrafts also generate wake turbulence. So you'll see this is another diagram showing that airflow over the wing. It just shows it hitting the upper camber and having to travel that further distance than below the wing. You'll see high pressure below, low pressure above. See the faster air is above, slower below, and this is creating an upward force or lift. So now that we've talked about lift and how that is created, we can talk about wingtip vortices. So the formation of wingtip vortices is created when the air above and below the airfoil is drawn around the wingtip, creating a vortex. And all a vortex is a mass of whirling air, as you see in this diagram. So how did these wingtip vortices circulate? So after they meet at that wingtip, they circulate upward, outward, and around each tip. And you'll see also near the bottom of the diagram, I have all those arrows kind of pointing down and away from the aircraft. As that aircraft moves along, the wingtip vortices will sink below its path and kind of dissipate outward. Now we'll talk about the strength of wake turbulence and how it varies. So strength of the vortices is determined by the weight, speed, and configuration of an aircraft. So the most dangerous wake turbulence is created by heavy, slow, and clean aircraft. So why should we be aware of wake turbulence? So wake turbulence can cause an uncontrolled roll and yaw of your aircraft. It can also, if you hit wake turbulence at a bad enough spot, it can cause seek rates up to 1,000 feet a minute. It can also cause structural damage. Some severe cases can cause you to lose control over your aircraft. It can cause and in some mild cases, you'll just feel rocking in your wings and slight turbulence. So how do we avoid this wake turbulence? You'll see here, like we talked about earlier, when following behind a larger aircraft, we know their wingtip vortices kind of travel downward as this aircraft goes along. Their seek rate is several hundred feet a minute, so we want to avoid flying directly behind larger aircrafts and below their path. I have this first paragraph starred because it is very important. So the most critical phases to encounter wake turbulence is during takeoff and landing, and that is because you're at such low altitudes that if you do encounter it, and you lose complete control of your aircraft, you're not going to have a lot of time to recover. So here's a few tips and tricks to kind of avoid ever getting yourself into that situation. So taking off behind a large aircraft that has just departed. So you're going to want to rotate before their rotation point. So we'll watch wherever they rotate, we're going to rotate before them. We are going to climb above their path and turn early away from their path. This will keep us clear of any wingtip vortices they are creating. Let's say we are taking off behind a large aircraft that is landing. We want to rotate after their touchdown point, because after they've touched down, they're not creating lift, therefore they are not creating wingtip vortices. Let's say we are landing behind a large aircraft that is also coming into land. We're going to watch what their glide path is. We're going to stay well above it, and we're going to land beyond their touchdown point. Landing behind a large aircraft that is departing. So you're going to want to land before their point of rotation. Once again, before they've rotated, they haven't started creating those vortices yet. So if we land before their point, we will be clear of them. And then en route, to stay clear of any wake turbulence, we're going to avoid flying directly behind any larger aircraft and below them. Like we said earlier, those wingtip vortices sink behind the aircraft, and we want to avoid that. How does wind affect wingtip vortices? So wind speed and direction affects the path and duration of wingtip vortices. When we have calm winds, they tend to kind of stay over the runway. If we have any type of crosswind, this will kind of help push the wingtip vortices in the direction of the wind and clear those a little bit quicker for us. Our worst case scenario, wind-wise, concerning wingtip vortices is a light quartering tailwind. This causes these vortices to remain over the runway for longer periods of time than we would want them to. So some extra tips and tricks. We talk about some scenarios. So at towered airports, we hear this a lot at our airport. Sometimes they'll clear us to take off or land, and they'll say caution wake turbulence. And they're just warning us of the possibility of us encountering them. So that gives us a good heads up to maybe situate ourselves to where we can avoid them better. So another tip is to wait 3 minutes after a large aircraft rotates to ensure you remain clear of their wingtip vortices. So anytime you have a large aircraft departing in front of you, and you might be worried about their wake turbulence, watch when they rotate. As soon as they rotate, start that timer. After 3 minutes, you should be safe from their vortices. Also, if you are coming in and you know you need to land short, or you need to take off before the larger plane's rotation point, maybe consider executing a short field takeoff or a short field landing to ensure you will indeed hit that point. Also, another way to kind of separate yourself, so you can always ask a controller if you're coming into a towered airport. If you're unsure of your separation between you and the other large aircraft, maybe ask them for their ground speed, the distance between you guys, and that way you can better situate yourself to stay clear of them. And also, warning or not, if the controller does not give you warning, even when you're going into a controlled airport, it is up to you to avoid these, to avoid the wake turbulence. So just be aware and cautious. And if you want any more information on wake turbulence, you can look in the AIM Chapter 7, Section 4.